Okay, so we're going to go back. So let's recap what we know from GCSE about atoms. All atoms contain 3 particles, yeah? They contain, this is going to be so easy after going to. They contain protons, neutrons, and electrons. Yeah, happy with that? Okay. And we can do, we can have the mass of each one. So I use atomic mass units to make it easy. If we use things like kilograms or grams, it would be tiny. So the mass of a proton is 1, neutron is 1, an electron?
1 over 200,000 or 2,000?
2,000, yeah, very small. Basically, this is small, doesn't really matter. And the other thing you need that could come up on the paper is the charge. Charge on a proton. Yeah, neutron. And electrons and minus 1. Yeah, cool. And in an atom, the number of protons is equal to the number of electrons. But the number of neutrons varies. The proton, where would you find that? How many protons? Where does that come from?
Atomic number.
Yeah, which you can look up on your periodic table. So the number of electrons is also going to come from the atomic number. Can you find the number of neutrons from the periodic table?
Mass number minus atomic number.
Is mass number on the periodic table? What's on the periodic table? Relative atomic mass gives the average. So for the mass number, to find the number of neutrons, I have to tell you the mass number of the isotope I'm talking about. Because remember, all atoms are made up of different isotopes. What is an isotope?
The same element but with different mass.
So they have the same
number of protons but different number of neutrons.
atomic number, but different number of neutrons. Again, very, very common, very common question that comes up in that first part of the paper. What are isotopes, or how do I spell isotopes? What's an isotope? Same atomic number, but different number of neutrons. These two you can find out from your periodic table. That you can't find out from your periodic table. Where are these 2 guys in your atom? These 2 guys are in your nucleus. And these are in, they're in shells. At the moment, we're thinking GCSE, they're just in the shells orbiting around the nucleus. So, typical atom, in an atom, most of the mass is in the nucleus, and the electrons are just fuzzing around the outside. And that's kind of like looking at the solar system model of the atom, where we have the protons and neutrons, where we think of being the sun, and the electrons think of the planet. So that's kind of like GCSE stuff. So atomic number we said was number of protons. Mass number we need to know. Mass number, if we had to write out mass number, what does that equal? Protons, plus neutrons that we'll be told. So normally we're told the mass number and asked to work out the number of neutrons. So we just take away from it the atomic number. So that's easy peasy. That's okay. Let's have a look. What is an ion then?
A charged atom.
Yeah, an ion is an atom that has lost or gained electrons. So key thing, in an ion, these 2 haven't changed at all. It's only this number that has changed. So sometimes they'll give you a typical question. So let's say we've got, let's do carbon 12, carbon 13, and carbon 12 plus. And they want us to calculate how many protons, how many neutrons, and how many electrons we have. So carbon, atomic number 6 is going to be 6, 6, 6. That's a bit
We were enchanted in
Oh
six
dear.
words.
Six. Number of neutrons?
Six.
6. Woo, that's right. And 6. Number of electrons? 6. What about this guy? 5. Yeah, he's lost an electron because he's a positive charge. So that's quite a typical starter question in the AS exam. So here we go. So definitions we need to know. The relative atomic mass. So relative atomic mass you need to be able to know. I won't write it out. It is the weighted mean mass. I'm going to read it out. The weighted mean mass of an atom of an element compared with 1/12 the mass of an atom of carbon-12. So you've got to be able to work that out. So you must know that definition.
Do we have to know that for A2?
Yeah, you'd be expected to. It's really unlikely to come up.
Can't remember.
But remember, it's all synoptic, so you never know. What they want you often to do is actually to be able to calculate the relative atomic mass. So sometimes they say, okay, you've got 2 isotopes. In a sample of silicon, 92% of it is silicon 28, and I have got 5% of silicon 29, and that leaves 3% of silicon 30.
This is different from MR, isn't it?
Yes, that's right, yeah. So this is how you know those figures that we have on the periodic table, the relative atomic mass. What is the relative atomic mass of silicon? So what is the relative atomic mass of silicon? So again, typical question. How do we do this? Remember, relative is the weighted mean mass. So we have to take account, just as a baseline figure, what's it going to be? What is it about its value? Is it going to be nearest 28, 29 or 30?
28, because it's a majority.
Yeah, it's going to be near 28, isn't it? How do we do it? Maybe when we do...
Over 100 because it's percent times
Yeah.
the little number, times the isotope.
Yeah, so 92 over 100 times 28, plus 5 over 100 times 29, plus 3 over 100 times 30. Now, most people are happy chappies doing that. Where they go wrong is they do it incorrectly in their calculator. So I would work out the brackets separately and then do it. Hopefully, if you do the brackets right, you get it to be 28.11. Things to watch out for. Sometimes they ask it for a certain number of significant figures. So I've done this to 4. Sometimes they'll say, now give you answer to 3 significant figures. So don't lose that mark by not doing it to 3. So if they then said 2, 3, sig, you change this to 28.1. Sorry?
Unless there was a 5 in the end, only 28.2.
Yeah, that's right, yeah. So just make sure that you do that. So that's, and then you've also got relative isotopic mass. That's the mass of an atom of an isotope. So that's always going to be a whole number.
Yeah.
Because it's just that, yeah, you won't have that. Then you have the relative molecular mass, which is where, you talk about you add up all the relative atomic masses to get it of a molecule. So that's what we use when we do molecule. Relative formula mass is just a similar thing, but you use that for ionic compounds. So it's kind of the same thing. Molecular mass, really, you should be talking about molecules. Relative formula mass really is ionic substances, because relative molecular mass doesn't really work for ionic things, because in an ionic lattice you've got many of these all joined together. But if you think about it, for methane, say, that is an entity in its little molecular methane. So for that one it'd be relative formula mass, for that one it'd be relative molecular mass. So key things, learn your definitions, because it's maybe 3 easy peasy marks. Make sure you can do that as well.